All right, guys, continuing our Unit 7 test review. For these two questions, we're going to do the opposite of what we did in the questions before, where we took the equation and made a graph. Now we're going to be using the graph to try to create the equation. So we need to just mark and label as much as we can. And we're going to start by reading the instructions. Okay, it says use the dots to indicate one wave cycle. That means the wave is going to start at the first dot and end at the second dot. So if you have a ruler, protractor, edge of your ID, whatever, I like to go ahead and put vertical lines here. And that helps me just kind of keep track of where everything's located. So my start on the x-axis is at pi over 4. My end is at 9 pi over 4. Now, this start is high. The fact that this is high lets me know that it's a cosine function and that it is not reflected. The vertical shift comes from the midline, and this has a midline at 1, which means my graph's been moved up 1. The amplitude comes from the distance from the midline to the peak of a crest or to the low of a trough. And so the distance from 1 to 3 is 2, and the distance from -1 to 1 is also 2, which means my amplitude is 2. Horizontal shift comes from my starting point. Normally this graph would start on 0, but it's been shifted to the right, and it's been shifted by an amount of pi over 4. So it's been moved right pi over 4. Period is this distance, the distance of one wave cycle. So there's multiple ways you can do this. A lot of you might be able to just look at this and tell what the difference is. I like to take the final one, which is the last one, and subtract the initial one. So if I have 9 pi over 4 and I take away one of those, that leaves me with 8 pi over 4. That can be reduced if you want to 2 pi. Might be helpful to leave it with a 4. Depends on what information you need. B comes from, excuse me, since I'm using radians, 2 pi over the period, which I just found, which gives me 2 pi over 2 pi. Any number divided by itself is 1. So I have a b value of 1. Now, this is a cosine function, so it has a domain of all real numbers. It has a range of -1 to 3. And because of that, the distance covered is 4 vertically. The equation for this is going to be f of x equals, and I'm going to start with my vertical shift, 1. It hasn't been reflected, so I'm going to leave this a plus. Amplitude is 2. It's a cosine graph. My b value is 1, so I don't really have to put anything, but if you wanted to, you could still put a 1 there just so you're sure you're putting all your information. It's radians, so I'm going to say x, and it's been moved to the right, so I'm going to say minus pi over 4. And there's my final equation from this graph. Moving ahead, we're doing the same thing but in degrees. So the first thing I want to do is I want to find that start. And I want to find that finishing point. This graph starts at -2 and ends at 2. It also starts in the center, which immediately tells me that this is a sine graph. Not only does it start in the center, it starts by going up. It starts by going up, which means it has not been reflected. Vertical shift comes from the midline, which is 0.6, which tells me this graph's been moved up 0.6. The top line is 0.9, and the bottom is 0.3. So that gives me an amplitude of 0.3 because that's the distance between all those lines. Normally this graph would start at 0, but it's been moved to the left. It's been moved to the left by 2. The period, again, I like to take the final number and subtract the beginning number. When you take away a negative number, it's the same thing as adding. So my period is going to be 4. And my b value is going to be 2 pi over the period, 4, which reduces to half. Now, I did do a little mistake there. Made a little mistake. This is supposed to be in degrees. So I could just convert that. Pi over 2 is 90. Or I could do 360 over 4, which is 90. All the same thing. So I've got my, sorry, I kind of ran out of room there. Let me just rewrite this all real quick. It's going to bug me. All right. This is a sine graph, so it's got a domain of all real numbers. It has a range. The lowest y value is 0.3, and the highest is 0.9. And the total vertical distance from 0.3 to 0.9 is 0.6. So I've got all my information. The next thing I need to do is actually write the equation. The equation is going to be f of x equals, my vertical shift was up 0.6. This was not reflected, so I'm going to say plus. The amplitude was 0.3. It was a sine graph. My b value is 90. I'm using degrees, so I'm going to say theta. And I moved to the left, so I'm going to say plus 2. And that should be my correct equation. Now, for this next section, you're going to need your calculator. I have one, and I can open one on my iPad, but it doesn't really get along with my Notes app. So I will be working these off screen, but it is important that you try to practice these yourself so that you can get used to using all the calculator functions. So first thing you need to do is make sure your calculator is in the correct mode. These problems are in radians. So use radians. Make sure your mode is correct. Next, you need to be sure of what the question is asking for. Is it asking you for an input or an output? Sometimes they give you the input. That's what you plug into the equation, and that means you're looking for an output, which is an answer. But sometimes, like on these b values, they tell you what the output is, and you have to see what inputs get you that answer. So let's try this out. With number 8, you're going to type this into your calculator, not into Y1. You're going to type it in on your normal calculator screen. And we are looking for F5, which means instead of the X right there, you're going to put in a 5. When you type this into your calculator, 6 plus 3 cosine, you got to then put pi over 4, and instead of x, you're going to put 5 plus 6.1. You close all your parentheses, and you should get 3.719. It's 7187, which means you need to round up. And it says in the instructions, round to the nearest thousandth, 3 decimal places. while we're on this type of solving, let's go ahead and do 9a, which means where that x is, we're going to put in 12.7. So we can do 9 plus 6 sine pi over 3. Instead of x, we're going to put 12.7 plus 5, close both parentheses, and we get an answer of 7.146. So they gave us the input. We needed to find the solution or the output. Now we're going to reverse that. Now they are telling us the answer is 5.5. What inputs get you that answer? You're looking for the first 3 positive answers. So you're going to need to go on your calculator and go to y equals. You need to put what's in the parentheses here as y1, and you need to put 5.5 as y2. Gonna go ahead and do that real quick. When you get it, hit graph. Now on this particular one, you don't have to draw this, but on this particular one, there is a spot that looks like it might possibly be positive. It's like right there on the line, okay? It looks like it might be positive. Kind of in here. I know my drawing's not perfect, but it kind of looks there. You would want to go ahead and test that to see. If it's too close to tell if it's negative or not, test it to see. Now remember, the way you do this on your calculator, you need to do second, trace, enter, times 2. And then your screen, or excuse me, I skipped a button, sorry. Second, trace, 5, enter, times 2. When you get to this point, your screen will say, guess, question mark, and you need to use your arrows, your arrow keys, to bring your cursor to the location you want. So you want to move the cursor. And then at the very end, you want to hit enter one more time. And it should give you the X value. So if we trace this one out, second, trace, 5, enter, enter. My screen says guess. I'm dragging my X over. When I do that first one, it is actually negative 0.313. So again, on my screen, it's very hard to see if that was positive or not. So you would just want to confirm it to be safe. That means I need to find this answer as my first positive, this one as my second, and this one as my third. So again, I'm going to do this real quickly. I'm going to second, trace, 5, enter, enter. I'm going to drag over to that next one. I'm going to hit enter, and it gives me 4.113. I'm going to second, trace, 5, enter, enter. Go over to the next. Hit enter. It gives me 7.687. And then I'm going to do it one more time. Second, trace, 5, enter, enter. When it says guess, I'm going to move my cursor over to that third intersection, and I get 12.113. For this next one, I'm going to let you do it because it takes too long to do it off screen, and I need to keep this video concise. So let's look at 10 through 14. This is really similar to our 7.5 notes, our application problems. It says you're sitting on the deck of a river steamboat. As the paddle wheel turns, a point on the paddle blade is moved in such a way that its distance d from the water's surface is a sinusoidal function of time. When your stopwatch reads 7 seconds, the point is at its highest, 20 feet above the water's surface. The wheel's diameter is 24 feet and it completes a revolution every 16 seconds. Use radians. This is actually the exact same one we worked in class. So to let you know, a good starting point is always an extreme. Is there a maximum or a minimum? And this question tells me that there's a maximum of 20 and that it happens when a stopwatch says 7 seconds. Next, the wheel's diameter is 24 feet. So if the highest point is 20, my lowest point needs to span 24 feet. So if you say, what's 20 minus 24? That brings me down to my lowest point, which is -4. And if you ask yourself, what does it mean to be negative? Why is this number negative? -4. It's actually because it is beneath the surface of the water. If you were on a boat paddling and you never went below the surface of the water or into the water, you wouldn't actually go anywhere. And so we're going to call our water level here, we are going to call it 0. And I'm going to write on the other side, well, that's where my equation goes. I'm going to write water level. All right, so that maximum at 20 is where we start. That's going to be up here, which indicates that I start high, which also tells me this is a cosine function that has not been reflected. Vertical shift is my midline, so I need to think of a number that's between -4 and 20, perfectly in the middle. Well, one way you can do this is you can take this diameter, 24, and split it in half. That gives you 12. That's going to be your amplitude, and that means you need to go from 20 down 12. That'll bring you to 8. And then you can just double check, is the difference between 8 and -4 also 12? It is. So that confirms that our amplitude is 12. It also confirms that our midline is 8, and so we've been moved up 8. Horizontal shift. This whole graph starts at +7, which means we move to the right 7. The period is how long it takes to complete one trip or rotation, and it says right here it completes a revolution every 16 seconds. So that's our period. And then our critical points will be period over 4. 16 over 4 is just 4. So what that tells me is I'm counting by 4s. I'm going 11, 15, 19, 23, and the difference between 7 and 23 should be 16, which it is. So I'm going to just keep counting by 4s until I run out of lines and I get there at 39. So I'm going from 7 to 39. Last thing we need to do is just graph our critical point. So if I start high, then I'm going to go middle low, middle high, middle low, middle high. And I can also go ahead and connect the dots here. So now, let's write the equation. The vertical shift was 8, so we're going to say f of x equals 8. And my it was not reflected, so I'm going to say plus. Amplitude's 12, and it's a cosine function. My b value is 16. Wait, just kidding. I haven't found my b value yet. B equals, this is in radians. B equals 2 pi over the period, which is 16, which is pi over 8. So my b value is pi over 8. So I'm going to come over here, pi over 8 It's in radians, so I'm going to use x. I move to the right 7, so I'm going to subtract 7. And I think I can just fit it on there. Perfect. There is my equation for this sinusoidal function. This says that what first positive value is the point at the water's surface. So we're looking, where is my graph at the water's surface? It happens here at a little over 11 seconds. But what you have to keep in mind is that this graph also goes this direction. And since we're starting at 7, you have to assume that there's a point over here, somewhere between 0 and 7, where I'm also at the water's surface. So we want to find that out through our graphing calculator. So we would want to put y1 on your calculator. You would want to put our equation. And you would want to put y2 at 0. And then you would want to trace the first positive intersection. It says at that first positive value is the point going into the water or coming out of the water. And if you can go back to our graph here, if we look at this point, our graph is on the way up. It's on the way up, which means that point on my wheel is traveling up and out of the water. It says, how far above the surface of the water is the point when your stopwatch reads 2 seconds? Stopwatch and seconds indicate time. And if we look at our function here, time is the x value, which is my input. All I need to do is in my calculator, I need to clear out of the graph and just go to my regular calculator mode, and I need to do 8 plus 12 cosine pi over 8. And instead of x, I'm going to put 2 minus 7. That should give you the solution. Make sure you round to 3 decimal places. All right, last section, 15 through 19. It said researchers find a creature from an alien planet and discover that its body temperature varies sinusoidally with time. 22 minutes after they start timing, it reaches a high of 130 degrees Fahrenheit. That is a major clue right there. 1, we are starting at the highest point of 130. That means this is going to go high to low, back to high, back to low, back to high. The next thing it tells me is since this starts high, it is a cosine graph that has not been reflected. Now, this high temperature also happened at 22 minutes. So I'm going to put on 22 as the first point on my x-axis. It says 20 minutes after that, it reaches its next low of 106. If we are measuring our graph, this is the high, this is the next low, and the low is 106. That happened 20 minutes later. So if I started at 22 and I went to 20 minutes later, that would bring me to 42. And then if I just kept going every other line, adding 20, that would help me get a lot of numbers from my x-axis. After I complete that step, I need to figure out what my vertical shift is, which is going to be my midline, and will also help me figure out my amplitude. So let's do this again. Let's look at the total vertical distance. If I go from 106 to 130, how much distance have I covered? I have covered 24. And if I cut that in half, that should be my amplitude, which means my midline will be 12 less than 130, which is 118, and 12 more than 106, which is 118. So that worked out perfectly for both. Vertical shift is up 118. Horizontal shift is right 22, because I'm not starting at 0, I'm starting at 22. Period is going to be how much you cover in one cycle. My final number is 62. My first number is 22. From 62 minus 22 is 40. My critical points will be 40, the period, divided by 4, which is 10. Means every little dot here just goes up 10. And if you look, that actually works out perfectly. And then we need our B value. B equals, we're working in radians, so 2 pi over the period. 2 pi over 40. That can reduce to pi over 20. I've got all my information now. I need to write an equation. I'm going to write f of x equals, I'm going to go to my vertical shift, 118. Hasn't been reflected, so I'm going to say plus. For my a value, my amplitude, I'm going to put 12. For my trig function, it's cosine. My b value, pi over 20. I am in radians, so I'm going to use an x. I'm moving to the right, so I'm going to say minus 22. And then I'll close the parentheses. This asks, what was the temperature 12 minutes after they started timing? 12 is an input. So I need to just plug in a 12. Okay, I need to plug in a 12. That will give me my time. So I'm going to do in my calculator 118 plus 12 cosine times pi over 20, and I'm going to drop down here, times 12 minus 22, close my parentheses. If I work this out, I get, 1 second, 118 plus 12 cosine pi over 20. 12 minus 22. I got that the temperature, 12 minutes, will be 118. If you look, that's my midline. And also, you know, all these marks are 10. So if I went back 10 this way, that would bring me to 12. And I should be right there on the middle again. So that actually makes perfect sense that I would be back at 118. Now, what was the temperature 30 minutes before they started timing? You could, you know, kind of reverse engineer this again. 30 minutes is, again, if I'm working backwards, I know I don't have a ton of room here. I don't want to confuse you too much, but if I'm working backwards, that was minus 10. Sorry, I'm going for 12 minutes after. I just realized I made a mistake here. 12 minutes after would be 34. I'm sorry, I made a mistake on that last one. I just plugged in a 12, but I can't do that. It's 12 minutes after it started, so it should be 34. So let me work that out real quick. 34. My temperature would be 114.292. All right. Now, 30 minutes before, the same concept kind of works here. This would be minus 10. That would bring me to the middle. I'd go back 10 more. That would bring me low. And I'd go back 10 more, and that would bring me to the middle. So 30 minutes before should be 118. If you wanted to, you could also plug it into your calculator. You could say 118 plus 12 cosine and pi over 20. Now our x, think about it, we started at 22. So if we subtracted 30 from that, since it's 30 minutes before, 22 minus 30 brings me at -8. So I would put in a -8 as my input, minus 22. And if you type that into your calculator, you should get 118. Now, for this last one, it says find the first 3 times at which the temperature was 114. So what you need to do is use your calculator, and for y1, you're going to type in the equation. Just like this, you're going to put your x. And then for y2, you want to know all the places where the output was 114. So I'll help you get started here. I'm not going to have time to do all of them in this video, but I've got 118 plus 12 cosine. We've got pi over 20, and then x minus 22. And then I want to know all the places that it equals 114. I'm going to graph this out real quick. Graph is thinking. Still thinking. Now, because these numbers are so much bigger while my graph is loading, you're probably going to have to adjust your graph window. Like mine's in standard right now, and I don't see anything. So if you think about it, this graph has been shifted up 118, and it has a maximum of 130. So maybe make your y max somewhere like 150. You could even change your y scale to tens so that it fits a little better. As you are working this out, if you can't see enough right or left, you need to change your x max or x minimum. Mine's thinking again. If you have to reset your window, if you have to do that at all on your graph, it's zoom 6. That will reset your window. So I'm on mine right now. I'm changing my y maximum to 150. I'm also going to let my y count by tens. I'm going to see what that looks like. I can finally see some of the graph on here. It still doesn't look great because it seems like it's really like stretched out. So I'm going to change my x's. I'm going to make the max, I'm going to say 200, and I'm going to also make the x scale tens so that I can see everything a little bit better. So just to keep you with the changes, I'll go on x max at 200, and I went x scale at 10. That just means it's counting by tens. This actually helped a bunch. Now I can second trace 5, enter. And I want to find the first 3 positive intersections. So I'm going to do the first, and I get 9.837. I'm going to do the second. I said I wasn't going to do them all, but I've put in this much work, so I might as well. I'm going to do the second, and I get 34.163. And I'm going to do the last, and I get 49.837. And something I pointed out in class is that the difference between every other one should be the period. If you look back up here, we had a period of 40. See how from 9 to 49, I added 40? That's my wave period. So every other answer will be plus 40. If, just to take this one more step further, sorry, I know I jacked that up a little bit right there. Let me move this. There, that kind of fixed it. If they ask you to find the fourth one, it would be the second plus 40. And you could keep that pattern going and going and going without having to trace in your calculator every time. All right, that's everything. I hope this helps. I hope you do well on your test. Don't forget to study. Watch this over the weekend, and good luck.